morning all of you, and today I'm going to deal with matrix connected with vectors, and this is a very fertile ground on which JEE advanced can definitely ask question. So here we go. Let's say if you have a vector A, B, C, I'm representing it as an ordered triplet, and we cross with, let's say, another vector X, Y. So of course in our entire discussion ABC is treated as I cap plus BJ cap plus CK cap. तो अगर आप क्रॉस प्रोडक्ट लोगे, so all of you know how to take the cross product. We have IJK ABC XYG, and this gives us I times BZ minus CY minus J times BZ minus CX and plus K times AY minus BX. The point is, can we represent this cross product in the language of matrix? Okay, so let's give a try. Now, of course, the idea is to produce terms like BZ minus CY in this. So if I consider a matrix, let's say SQ symmetric matrix 0 minus CB, C0 minus A. This motivation is coming as to create these chunks, right? Minus A, and 0. So clearly it's SQ symmetric matrix because this guy is 0, minus since is reflection, negative reflection of each other. Now, what is the speciality of this matrix? Let's say if I multiply this guy with a vector x, y, z, let's see what is the result. So of course we'll have minus cx minus cy minus cy plus bz. Second is gonna be cx minus az, and third is minus bx plus ay, and which you can clearly see this is the I component, the second part is j component, and the third part is k component. So what I can tell is, if I have any vector b which is given by, let's say, abc, and we have got other vector x which is given by xyz. So what we can see, if you have any vector b, and let's say we have got any vector x which is given by xyz, so b cross s, this is cross product, can be simply written as the matrix A times x vectors, where A is written as 3 cross 3 matrix and x is a column vector or a column matrix, right? The more beautiful aspect of this is we can even think of triple cross product, so b cross x. It's better if I take the another name to this vector x in bold. Okay, so this x represents the column vector x, y, z. So v cross b cross x, as we know from cross product, is going to be v dot x to b vector minus v dot b into x vector. So can we still represent this? And it's not very hard to see, as we can also represent dot product in the matrix form. And what is b dot x? So that's gonna be, ax plus by plus cz. So v dot x box we can think like this. If I think of a matrix, let's say x, y, g, and then if I multiply with abc, so clearly this is dot product, which is ax plus by plus cz, because it will give 1 cross 1 matrix. We have 1 cross 3, 3 cross 1, so resultant is 1 cross 1. So in that sense I can tell what is v dot x. V dot x is nothing but b transpose times x column vector. So these are two notations. So the takeaway from here is ax can simply be written as v cross x, where A is a corresponding matrix, and b dot x can be represented in terms of b transpose x. Using this both idea, now even we can represent a cross triple product in language of matrix, and that will be simply a square times x. So if I will take, let's say, a square, so we have 0 minus cb, c 0 minus a minus b e0. You take its square and then multiply with column vector x, y, j. Of course, if you do so you are going to get some value of matrix, and by squaring the matrix that I am going is minus b square minus c square, ab ac, ab minus a square minus c square, bc, ac, bc, and minus a square minus b square. So this times x, y, j. Okay, and this will nothing but it will be the representation of the product, provided here of course I have used a normalization, provided if let's say a square plus b square plus c square equal to, it means a square x has got some physical meaning. Okay, basically what we can do is b cross x can be written as simply b dot x times b vector minus b dot b, which is mod b square times x vector. So if you want, if suppose mod of b is 1, which means abc is a unit vector, which means abc, this order triplet is unit vector, then of course this expression can also be written as b dot x times b and minus x bar, which is fundamentally I've written here. So if we'll square this, provided a square plus b square plus c square is 1, then this will give this answer. Okay, so that will be easier to manipulate. And that is having very cool geometrical meaning, because it simply tells if we have got n vector as, let's say abc, which is a unit vector in this case. Okay, so it can easily be shown, and very surprising, that the orthogonal projection of any vector x, so let's say if we have any vector x, the orthogonal projection of x into the plane perpendicular to this n cap, and let's say this plane is passing through origin. Okay, and this plane is perpendicular to this n cap. So if I'll take the orthogonal projection of x on this plane, okay, so this vector that you will get, this vector that will have simply component as a square x. In fact, it will have minus a square x because of the sign notation. Okay, so I can tell x minus x dot n times n equals minus a square times x, where x is a column vector, remember. Okay, so a square x fundamentally represents negative of that projection, so it's like projection vector opposite to this. Now this idea might seem not very obvious to connect with the vector and matrix world, लेकिन it has its great significance, क्योंकि अब बहुत प्रॉब्लम ऐसा सेट किया जा सकता है जिसमें दे आर गिविंग यू मैट्रिक्स इक्वेशन, लेकिन वहाँ पे जो आइडियाज़ आ रहे हैं वो आपको वेक्टर्स का है, सो दैट यू कैन ईजिली विजुअलाइज दोज मैट्रिक्स इक्वेशन. एंड वन सच एग्जाम्पल इज दिस. So you can just read the question framed by me and let's see if you can do it or not. Now the question definitely revolves around the idea which I have discussed right now.